Hello, protocols, packets, and programs. We leave the ghosts and goblins of October behind us and take a moment to recover from the tales of horror, madness, and danger that only a Cybersecurity Awareness Month can bring. Which means this week we chat with Karl Triebes from Imperva about API security, bad bots, bad behavior, and good designs. In the news segment, puny parsing in OpenSSL, missing authentication in Azure's notebooks, regressive response to security research, security documentation, and more. Stay aware and stay tuned for Application Security Weekly.
This is Security Weekly, for security professionals, by security professionals. It's the show to learn the latest tools, techniques, and processes necessary to understand DevOps, application security, and cloud security. Your trusted source for the latest application security news. It's time for Application Security Weekly.
UFOs are everywhere. That's right. UFOs, unidentified file objects, are hiding in files in your cloud apps and storage. UFOs can contain malware that exfiltrates data or deploys ransomware. 70% of UFOs in files can't be detected or prevented by traditional scanning solutions like antivirus and sandboxing. That's where Vitero comes in. Vitero prevents UFOs before they hitch a ride in on files in the cloud, without detection and without slowing down business. Learn more at securityweekly.com/Vitero. Your organization is building and updating business-critical web applications faster than ever. And with so much pressure to move fast, you may find yourself making trade-offs between innovation and security. Now you can build fast without sacrificing security with Invicta, the application security platform that helps your dev, sec, and ops teams work together to secure every website, web app, and API. With unparalleled accuracy, coverage, and automation, Invicta scales like no other AppSec solution. Discover why many of the world's largest organizations innovate securely with Invicta. Visit securityweekly.com/Invicta. This is episode 219, recorded November 7th, 2022. I'm your host, Mike Shima. I'm here with John Kinsella. Hello, John.
Good morning, Mike. How are you?
I'm doing quite well because we also have Akira Brand. Hello,
Yay.
Akira.
Hi, Mike. How's it going?
Very good. Good to see you again 2 weeks in a row. This is excellent. And guess what? We also need to hear from Security Weekly listeners. Leave us your feedback on Apple Podcasts and submit a screenshot to our giveaway form for a chance to win a $100 gift card from Hacker Warehouse. This giveaway will be open until the end of 2022. We appreciate your honest feedback so we can continue to make great content for all of you. Enter at securityweekly.com/giveaway. For over 3 decades, Karl Triebes has helped conceive and build products, services, and businesses for networking, application software, storage, and cloud. Prior, he was Executive Vice President of Product Development and CTO at F5. Triebes has held senior leadership positions with Amazon Web Services, Foundry Networks, and Alcatel. Hello, Karl. Thank you for joining us.
Hey, great to be here. Thanks again.
So it's wonderful to have you here, human, in person, because we're going to have to talk a little bit about some bots and their impact on API security. But maybe we start a little bit off of just, we've spoken about API security in the past, and API security is different from web security, but they still drive web applications. Maybe let's just hit about why API itself is so distinct or important as its own class.
Yeah, APIs fundamentally provide a mechanism for automation. That is, typical web applications are assuming, a human interaction, but, with the rise of DevOps, and also, being able to establish, basically, B2Bs are trying to exchange data, exchange, various forms of, share their business, if you will. They need to create these automation mechanisms, and APIs really are the lingua franca to support that. And they're fundamentally a bit different than your web application because, typically a web application, you have some sort of browse, you have like a web server. So let's say you're running Tomcat or something like that. And then behind it, you'll developed your application. And then there'll be a database sitting there in some ways. And there's a lot of mechanisms, that go around that, security mechanisms that have been around for many, many years, and practices around that organizations have implemented. So it's a well-known thing. The first web application firewall showed up, over 20 years ago, courtesy of Imperva. And then, of course, that market grew from there. And now they're ubiquitous. But APIs are fundamentally different because they allow access directly into the heart, typically, of your infrastructure. directly at your, databases. They bypass a lot of the normal mechanisms. And then the second part of that is they're managed by developers. They're not typically as managed by IT organizations in the same way. And so as such, they tend to be a lot more fluid. And then, with that fluidity comes more opportunities for exploits and things like that. So.
Yeah, and I like that description because it definitely, we're not talking about just cross-site scripting for that matter. There's possibly APIs could deliver it, but not as simple as those generic injection attacks, if you will. And we're talking more about the responsibility of those application developers for the application security. And this is where I want to explore a little bit about what are some fun API concerns or attacks or things that these developers have to think of, beyond just injection, beyond just or being responsible for, this, as you said, this is the hook into a data store, a hook into other services, microservice, a graph of services, if you will.
Yeah, absolutely. We look at it as four major categories of attacks with APIs. The first is authentication attacks, right? So it's credential abuse, token abuse, authentication bypass, those types of attacks. And those typically are well handled by API gateways because, I call API gateways typically fancy load balancers with authentication built in because they support that. And then there's also service abuse type attacks. And what we mean by that is distributed DDoS attacks or, large API call volumes to overwhelm these gateways or messaging structure level abuse, things like that where you're violating certain, constructs within the language itself or the API itself. And most of those tend to be okay, handled by API gateways, but then we start getting into the things that attack more the business logic. So the next two categories, there's malicious request type attacks. So that's like injections, schema validations. There's server-side request forgery, those types of attacks. There's also client agent bypass. These are bad bot type style attacks. And those are very difficult for gateways to deal with because these tend to be much more sophisticated type attacks that more align with your more traditional application attacks. And then on top of that, there's the, what I call the business logic abuse, kind of data theft attacks. And what those do is actually take advantage of, basically defects or within the application, the API itself, unanticipated access methods. Right. So you look like a valid user, you're coming in and you're doing invalid things. And so the best known version of that is called broken object level authorization, or BOLA. That's the number one of the OWASP top 10 for APIs. That's the number one exploit and the most fruitful. And in fact, you probably saw last year, there was a number of really well-known exploits, one against a well-known exercise products company. It was actually by a researcher, but they were able to, using that method, expose customer data of all their users. There's actually one for a large agricultural company too, as well. That was another through that specific attack. And there's other ones too, like data exfiltration, excessive data exposure, those types of attacks. But they all land in those four categories.
So, yeah, Karl, I'm going to back up 90 seconds, and I'm going to make a bit of a left-hand turn because I'm sort of curious your thoughts on something here. So you're talking about API gateways and sort of being separate from a load balancer, and I get that. I'm curious from where you're sitting with your sort of experience, not just current, but even previous lives. Why do we have this separate API gateway?
Yeah, it's specifically for that reason is that it uses a different access method. To allow APIs in. And so you have to do the authentication. So basically you have to know who the user is. And then there's an encrypted token that gets basically that happens in each API call. You wouldn't need these mechanisms as part of a typical web application workflow. And so what that means is they're validating who you are, and they're validating the type of access you have, and they're ensuring that throughout your session or how you're accessing the backend APIs, that they always are able to track you, right? That's a validated user, and that's key. You can't just open this thing up. There is public APIs, but there still is tokenization and things like that. I'm talking more about these private APIs.
Interesting, yeah. Fair point. But again, I'm just pure curiosity. I'm more familiar with your previous product over at F5 than I am with Imperva, but my recollection is you can do authentication checking on those devices to some degree, at least on some L7 load balancers. So is that still not good enough, or?
It's good enough from the point of view of doing the authorization. And, that's fine. That's actually frankly the easy part of all this is what I think is that the API gateways have been around for a while. As you point out, F5 actually has built in API gateway functionality because they've had identity and access management capability since I was there. We got that. In fact, we used actually our SSL VPN technology to provide all that. So all the single sign-on. So adding tokenization and other aspects to that, that's fairly straightforward. The more difficult aspect of it is you basically get these invalid users or these malicious users that are able to get past that they look like valid users. They're doing things like they're basically doing like ATO style attacks. They gain access. They look like a valid user. You can't differentiate them from a valid user. And then they start going and doing these things to exfiltrate data or take other malicious acts on the back end. So that's the thing. So it's not good enough just to try to validate who you are because it's too easy to steal credentials and to mask a good user. You actually have to have this layered defense model to ensure that you're protecting your APIs, especially since APIs tend to directly touch your database infrastructure, and databases tend to be largely unprotected from these types of attacks.
Yeah, that's what's interesting to me too, is the idea that the API gateways, it can make sense to have a centralization point or a unification point for I'll say a solved problem, not that it's necessarily been solved equally well across the board, but of that identity access management.
Right.
But one of the aspects you're hitting though is that there can be legitimate looking authenticated users that are taking bad behavior against that application. So they've passed successfully that authentication authorization, but now they're doing, I think a volumetric attack probably will hand wave away a bit since just a lot of bits that's just noise, but they're getting that business logic. And that to me is definitely an area where developers have to build up more threat models, be more aware of, well, I have a workflow that's supposed to go to A to B to C to D. Hopefully everyone will just follow that and will do what they're supposed to do. But I'm going to guess, leading question, that's probably not what really happens.
Yeah, exactly. It's hard for developer, when you have like a big team of developers, writing these APIs and adding to them and changing them constantly, it's very difficult to know what the unintended consequences are going to be. That is, you open up logic bugs. You may have logic bugs in not only how you present the data or what types of data is being presented, but to whom it's being presented. You may not have basically always observing all the access controls, or there may be other problems there. I'll give you one example, which was kind of interesting. It wasn't necessarily a business logic issue, but it was the fact that in one of those cases that I just mentioned with the agricultural company, what the researchers found was that developers had left open a new API calls that were not production ready and were not protected. And they accessed those and were able to access systems that they shouldn't have been able to access. And so there's all sorts of unintended consequences that can happen in these development environments, that being one of them. There's a lot of, I don't want to say sloppiness, but it's just very hard to get your hands around these big software developments like that. And that's why these external mechanisms are necessary. That's why you see, the API gateways, because you don't necessarily want the developers who are actually focused on conveying the business logic or, basically writing these APIs to allow easy connectivity to be the ones that try to be the gatekeepers to manage that. And that's part of the rise and the evolution of API gateways, was to provide kind of access controls. Now we're moving to like, how do you protect these deeper attacks, beyond that?
Karl, I have a question for you. Inside of these API gateways, and then of course you have the API design itself, who do you feel like is more responsible for this now? Is it an AppSec team, or is it the development team? And if it's the dev team, then how do you make sure everyone's on the same page and they're doing these sort of best practices?
Yeah, and that's the tricky part on the dev side, because developers are very opinionated about the tools that they use in their workflows. And so, anything that disrupts that workflow, this could be anything from, design code, unit test, and then, the pipelines and everything they use, to automate all those processes. Anything that gets in the middle of that slows them down. And developers are really good at working around things that slow them down. And so that's the challenge. And so what you have to, as a security team, at these companies or organizations, they need to provide mechanisms that do not disrupt that process, that are transparent largely to that process. And so one really good technique, and we do this, is we can run our API security solution against the site. We can show, things, we can discover all the endpoints, we can discover the data, the schemas and all that. But then we can provide back essentially a way for them to test, and validate future versions of their API. So when they release and they make any changes, they can validate and test against this. And so it's a very simple thing added to that workflow. And we recommend that as part of this, right? But beyond that, the security organization needs to have visibility in actually what's happening. And that's the number one thing we hear from our customers or our prospects is that, hey, help me figure out exactly what's going on here because I don't have any visibility into this. And that's the number one thing they need is that visibility. And so once they have that, then you can start implementing these other protections or mechanisms to ensure that you have high integrity, with your API environment, if you will.
Yeah, that aspect of that, where does the responsibility lie, or who does the responsibility fall to in terms of AppSec team or broader security team or the developers themselves, is interesting because we're talking about like the API gateway or having observability, which I can imagine to a degree, especially if we're talking about behaviors against an application. To a degree, NetFlow might help that kind of information just for volumetric attacks, but NetFlow and just IP address and port pairs aren't really going to tell you this is good behavior, bad behavior. So how much of this then needs to come from developers instrumenting an application, highlighting here's workflows that we're interested in, or here's more visibility that we can generate some of those signals for tools like this?
Yeah, there's certainly a lot of best practices around software development methodologies to ensure, and you absolutely want to implement those, to ensure the integrity of the code. And that comes from everything from, peer code reviews and, doing, penetration testing, doing static code analysis, dynamic code analysis. There's the ZAST and the DAST and all these different things that you can run. And those are all things that are important to do. But that doesn't necessarily prevent these types of business level attacks or logic attacks, because those can't actually map out your application. And so what we and often it's for example, you don't always know what types of data are being transacted, this PII data. And developers don't always know what would conform or not conform to being PII or sensitive data or things like that. They're just exchanging it or sharing it, right? And so a lot of times what we find now is that a customer will start looking at us going, "Wow, I had no idea this is the type of data that we're providing over our APIs," and want to set policies against that. There's a lot of gray areas in types of data or for example, or there's just certain. Developers are very focused on enablement, right? How do I make it easy for someone to get this information or do things? And even with best practices, that's kind of more what I'd call layer 8 kind of thinking. And that tends to be more, you need to have people that are setting policy and things like that. And the problem is there's a bit of a disjoint between the policymakers for security and the developers who are trying to implement, these applications, because they don't always speak the same language and understand what's actually happening. And so that's why I say you need these kind of transparent mechanisms to close these gaps. And so hence, that's why you saw API gateways rise. That's why API security is becoming such a thing now, because it can act transparently and provide those mechanisms so that you can start to close those gaps between what the security teams are requiring and what the development teams are actually doing.
And there's an aspect to that too. I think mentioning developers not necessarily knowing is this personal information or not. That I think comes from that idea of just you have hundreds, perhaps thousands of APIs in the back end. Organizations grow and just accrue these over time, and they just get lost from ownership, as opposed to here's a small team with a small set of APIs. So with that idea, then, I'm curious too, developers, they still must at least know these are some workflows. We're in e-commerce versus we're a bank versus we're social media or something like that still have either money, because I mentioned e-commerce and banking, or information, just social media. So even with those types of contexts in mind, are these types of API security and business logic do they change appreciably amongst them? From a developer perspective, can we say here's a couple things that we can do to expand more specifically rather than just a business logic of what we're trying to protect? Or how do we approach with more specifics of, have secure business logic?
Yeah, so part of that is, I go back to the data example, is knowing what data, what are the policies around the data, and how do I have enforcement and structures that prevent this happening inadvertently, or should I even be allowing this type of data to transact? And that's something you have to stay on top of because often your backends change, right? As you add new features or things, then your APIs have to expand to deal with that. And you're creating new content and creating new types of data out there. And a lot of times developers may not even know exactly what the data is. What they'll say is like, oh, this is an index in a database or something like that. It's abstracted. And so it's hard for them to get their heads around that, frankly. So you do need to have some from the data security side. So this goes back to, it's not just an API security feature. If you want to really best practices would have data security experts as part of that company using data security products, data access management products or things like that. In fact, we provide those at Imperva. And that helps avoid some of this inadvertent loss or inadvertent access to data that they shouldn't have access to. There's a lot of things like with permission settings and and problems like that. So there's a lot of ways that you can, get around the process. And that's kind of the issue is that, it's more of I think of it more as a statistical thing. That is, given time, someone's going to find a way into your systems. It's just, and the best thing you can do is to try to have multi-layered, defense and and stay up to date on the latest best practices, to prevent these types of exploits and make it harder. And so if you can make it hard enough, they'll move on to someone else, but you don't want to be a fat, juicy target, with low security at the end of the day. In fact, one thing you're talking about API, the API growth. I mean, today now in organizations on average, there's about 300 APIs, on average. And now up to, I think it's 80% of businesses now use APIs. So they're everywhere. In fact, if we look at our website, our cloud-based, we have we provide a cloud service. 70% of the traffic we see is API traffic. And so it's a massive, volume on the internet of API. So it's just become, like I said, the lingua franca of how applications or users are interacting. Your phone is, if you're using a mobile device, it's making API calls all over the place, as part of these applications. So they're everywhere. And so that's the challenge, is that when something's big and ubiquitous and it's, and everybody's got different practices and it's such a fractured, generally the API market's very fractured. You're going to get these kind of vulnerabilities based on that.
I'm curious. Sorry, Mike, real quick one on that is that stat around 70% of traffic you're seeing as APIs is pretty impressive. Do you think that's partially because static content is being pushed out closer to the edge also maybe, or? Yeah,
well, certainly the whole drive to distributed compute like IoT and, it is driving the rise of these, and placing content in the right places is driving a lot of the API usage out there because, again, you have your apps that are trying to pull from different sources. So like if I pull up, I don't know what, I can't think of a specific app on my phone, but you may have an app that's leveraging Google Maps. And then maybe it's taking advantage of something, it's like, I think the average app here is like 11 different APIs that it's accessing, something like that. As I recall some stat. Don't hold me accountable on that, but I remember something vaguely about that. But so, of course, mobile is just rising, so.
Yeah, I think that's where maybe related to what you were talking about just now too, is I'm trying in my head just make that distinction between here's reactive security, meaning the API exists, we're out there, so we want to see what's the behavior coming towards it, versus some proactive security to think about what are those threat models, what can we do that makes those attacks more difficult or impossible or reinforces a particular workflow. And that's where, I think back to, I go back once again to threat modeling and the idea that I've seen threat modeling succeed, but I've also seen threat modeling say, start with a data flow diagram, followed by crickets, because nobody has a data flow diagram. Right. Or if they do, it's outdated. So is there a workflow data diagram, a workflow diagram that exists here that is, at least conceptually, can help with understanding these types of business logic approaches? Or is it really just like sit down with your product manager and have a conversations between them of all the ways that this application could be abused?
My experience has been on the business logic side. It's so specific to your application and what you're trying to provide that it has to be generally managed through internal good best practices with your development organization and hardening. And so that goes back to my comments like on testing. You saw like DAS and SAS and things like that. Regular pen testing. Things like that can validate that. Having code reviews, structured code review process. Good internal architectural diagrams and data flows. Having strong. Translating the product team's actually helping translate system requirements down to engineering requirements, and being very disciplined around that. That those are best practices. Now, how well orgs follow that, it's all over the map. And I've seen a variety of different ways that happens. And so you just, so there's no silver bullet for fixing how developers develop. There's going to be bugs in code. I don't know how many downloads I've gotten on my Tesla because of various issues or problems. I had all sorts of weird issues, especially in the early days where the thing was crashing or doing odd behaviors and things like that. It's just a matter of, you're going to have bugs when you add code. And so you just have to plan for that. So, the way I would think of this more is, how do I reduce my attack surface? What is the way that I can minimize, bad actors gaining access to what I'm doing? And so one of the things we talked about, you mentioned bot earlier, most attacks carried out against APIs are on some sort of automated attacks, usually on bots of some sort. And so if you can eliminate or vastly reduce the amount of bad bot traffic specifically that's coming into your application, or the effect it has on your application, then you've taken a major step to reducing the opportunity for someone to exploit your APIs. ATO attacks account takeover attacks tend to be one of the big areas that come in, and that's always on a bot. They'll surveil, they'll come in low and slow, they'll do these very kind of complex things where they're rotating IP addresses and behaviors and things like that. And then it'll just sit there and look at like compromised credential lists and then, and use those and just keep hammering away until they get in. We saw a whole new class of attack, carding style attacks using these very sophisticated bot attacks, and they take advantage of APIs or other mechanisms, authentication mechanisms to gain access.
Yeah, I think we have a wonderful audio representation of APIs in action. I think we have some of your notifications going on in the background. So that's APIs at work, letting us know what's going on. Cool. You're pointing out here the carding attacks, these types of efforts, and what that's making me think of too is the ATO scenarios are interesting because there are bots that are taking over a human account that can have, in the best scenario, a FIDO key or some type of hardware security key that's really resistant to phishing, WebAuthn based. But there's also, B2B type of APIs, and those you can't really have multi-factor on them. So I'm curious what you've seen in terms of just that type of hardening, protecting that type of just API token. Authorization, authentication, that end.
Yeah, on the API side, obviously they've done a lot to, with the tokenization and all that. But again, with compromised credentials, it's impossible, in that scenario to really block that user. The next layer then becomes kind of user behaviors and being able to understand if this user is doing invalid things within the flow, and then being able to quarantine or take further action based upon that. That's really the only thing. Once you get past the authentication mechanism, it's really hard to do that. And the problem is, a lot of people use the same passwords. And then, they get, site will get compromised. They'll, the attackers get those hash keys and they'll just rotate those through using, ATO style attacks until they hit a hit. And once they get a hit, they're in, and the reason they do it, like, especially on carding, is there's a lot of money behind that. Maybe 1 out of 100,000 or 10,000 attacks actually works. Well, guess what? They're making a bunch of money off of that. They'll just play that numbers game and keep at it. It doesn't cost them anything. And so they'll just, it goes back to what I was saying about statistical attacks. You know what I mean? It's like, hey, I'll play the stat and see what happens,
So that's interesting because I'm going to repeat threat modeling again. That will be my word of the segment.
Yeah.
But one of the aspects of that, the reason I'm bringing it up, is we talk about the consequences or the impact. What's the worst case scenario here? When we're talking about carding, e-commerce, or banks, we can pull in money, and money, honestly, I think, is a pretty effective quantification of consequences of an attack. But if we're talking about a site that doesn't have that direct monetary link to its workflows, how help out developers? How can they try to point out that bots are going to be bad? Something bad will happen, and this is how bad it is. Therefore, we need to invest X to protect Y.
Yeah, I mean, and there's multiple things that bots are trying to take, right, or attackers are trying to take. I mean, getting direct dollars is one aspect of it, but there's a lot of indirect things that they're trying to do. They're trying to compromise like user lists. So if I can get if I get website from a particular website, if I can get user passwords and logins, then I can go sell that information. So I can get, so I steal that data, I can go make money off of that directly. Obviously, credit cards fall in that same category. There's whole classes of attack. They just get credit cards and they sell those credit cards. They may not actually use them directly. They'll just make them available, and there's various ways they classify that. In fact, there's a really great podcast, Darknet Diaries, that gets into a lot of these attacker profiles. And so I really enjoy kind of hearing it because they're so creative in how they're so incentivized and so creative. It's really hard to get around that. So, I go back to you talk about, what can developers do? Well, it's you make sure that, when you test, you're validating all the paths of your code. You make sure you walk through everything that's actually, and that way you'll know if there's any oddball, scenarios where somebody can come in and branch it or do something like that. Have that high integrity of validating. One thing I do know is that developers tend not to like to test, and validate. That's something they're not good at. So they need to do more of that and focus on that A/B scenario testing, validate, build the right test solutions. So, I tend to be a proponent of the test first approach, where you design the test first, then you design your code, and then you make sure that your code basically operates the way your test is defined. Things like that. There's a lot of mechanisms that have been tried and true out through the years that actually work. But it's again forcing that discipline, and that's the hardest thing. When you get in a big development organization, it's really hard to get that uniform, development across it, and that's why you see big exploits happen still in well-known code bases across the world. They're there. You can't help it.
Yeah, and to poke at that testing part again too, you didn't use these words, but you use this, I think, in spirit, is that it's not about unit testing, it's that functional testing. What are we exercising this sequence of code? And that's what's actually going to be protecting, rather than just say, yep, this was the number one, this wasn't, this was an integer, this was a letter, this was an email address, et cetera. That's not what is going to help us here on a proactive step.
Totally agree. Yeah, unit test is just a basic validation test. It's as you integrate the code, kind of back into your made code trunk, if you will, you need to have various levels of integration testing, and have good scenarios built around that. And then once the final system is complete, then you need to of course, have good validations around that. In fact, we were talking earlier a bit about chaos monkey style testing. And I'm a big proponent of that because I really like that style of test as kind of a final validation, because it throws a bunch of scenarios at things that stretch or push the system in ways that you wouldn't necessarily expect it to, or a developer may not have anticipated. Or you'll find, usually a lot of times, problems aren't just like any single thing. Usually most, decent development teams find it's usually a combination of events that occur that create, you have two or three things that occur, in the right sequence, and then boom, then you have an issue. And those are the hardest thing. Second, third order effects are the hardest thing to anticipate. So, so I think there's just a lot of different techniques development organizations can employ. But again, there's always going to be, I don't see a way around it. I've been doing this 30 years, and I've just never seen a way around it. And code just keeps getting more complex. In fact, one thing I should also mention is that probably one of the biggest exploited areas in a lot of these attacks is the open source. You use a lot of open source. And of course, open source has got its own chaos in terms of how it's being put together. But you always see CVEs. I mean, every week we see hundreds of new CVEs showing up. High, critical CVEs in these different open source code bases. And so that's what I mean, is that no matter what you do, you're always going to have some level of exposure, regardless of the integrity of your development process. That's always going to be there.
Yeah, I think that aspect of chaos monkey too is I think you mentioned this is very much that dependencies of what services do you depend on. Those aren't necessarily the type of functional testing that might be the front of your mind, and those are going to be those weird second order effect, third order effects that are going to come in and surprise you in unpleasant ways.
Yeah.
And one last thing I wanted to think of too, as we're talking on the developer side of the house, there is using open source, being diligent about applying security patches, of course, as well as just staying up to date on latest version patches to make sure that you have just quality software and take good software that's working as desired. As teams mature in this area, in other words, do you see a movement, or do you see them actually improving the observability at that layer 7, at that application layer, meaning they're instrumenting their code with, this looks weird, or here's a useful signal that we're going to have a data science team that we're going to work with. And that data science team then does their fancy math and their fancy if statements to say, bad behavior, good behavior, or, that type of data modeling on this information.
Yeah, I think there's more awareness of that, especially in large organizations, that as they get bigger and more structured, then they tend to bring in more of these practices. But, a lot of what goes out there are small startups or even moderate-sized startups that were built on code that was, hacked together very quickly, and then they just iterate. In fact, one of the big challenges is that one of the predominant methodologies these days is that kind of, release and iterate. And so when you're in that process, it's harder to build these kind of large structured processes into it and have this analysis. And so that a lot of that can happen offline. Now, there's a lot more tools out there, like I talked about SAST and DAST and things like that can show more of this behavioral component. But generally what will happen is if it gets in the way of getting a release out, and you have critical business needs, then that's going to go by the wayside, and it'll be a catch-up kind of philosophy. And a lot of times organizations, we find, don't, obviously know their security posture always, and often it takes some sort of breach or attack or something like that from actually to get religion around that, and then take more prescriptive actions to go deal with these types of these problems. And so that's why the challenge. That's why we always say with APIs, the best thing you can start with is at least get your hands around what your API, the structure of your APIs, the endpoints, what they're talking to, what types of data is being transacted. At least understand that, because then you can start making changes in your, your practices and procedures, within your development teams and how they implement things. And then beyond that, then you can start to employ deeper, protection mechanisms to keep that high integrity. But it's, like I said, the challenge is that's a bit of an arms race. That is, no matter how good a practice you put in software just gets bigger and more complex, and you're using more components and things like that. So you're forever kind of, chasing that goal, but it's, there's no real way to get there, if you ask me,
No, and Karl, we're going to have to release you shortly, but before we do, is there anything that we should be looking to iterating on in the future within this API security space?
Yeah, like I said, it's rapidly evolving. And everything's moving towards, in terms of automation, that's where applications and everything's moving. And so the problem's just going to get bigger and more complex. And that's why, we talk about, multi-layered approach to this. That is, obviously, we talked a lot today about tuning up practices around engineering, which is always a good thing. And I always recommend that, good hygienic, practices there. But it's also looking at how you're taking a layered approach of, I need visibility, I need to apply, DDoS and business, basically business continuity protections. I need to then provide mechanisms that prevent unauthorized access as best I can, and then reduce my attack surface, these different, attacker mechanisms like bots and things like that, and the business logic attacks. And so, kind of taking that very layered, pervasive approach, and then at the end of the day, then there's reporting and everything on top of that, so that you have a good visibility into actually what's happening. And those are all the key things I think you need to think about. And to be honest, I don't know how much that's really any different than what security was like 20 years ago, frankly. It's just that we have much more complex environments. The good practices haven't changed. It's really the methods and the complexity and, the tools that we use. Those are the things that have changed over time.
Indeed. Thank you very much, Karl. It's been a fun conversation.
All right. Yeah. Thank you. Good stuff.
Also want to thank John and Akira and all of our listeners. To learn more about Imperva, visit securityweekly.com/Imperva. And with that, we're going to release and iterate ourselves with a quick break and return with news of the week.